Okay, now start reading this. Just start reading it.
So aloud.
Sorry,
I read it on my own or do I read it aloud?
loud, loud.
Okay. Wave motion. It is the disturbance in the flow of molecules in a medium. Wave transfer energy from one point to another. There are two types of waves: progressive waves, which are traveling waves, and stationary waves, which are standing waves.
Okay.
Progressive wave.
Okay, so what is the wave? It is just the disturbance of the molecules. The way molecules flow, it's called wave. And we also can say that when the wave transfer energy from one point to another, wave always transfer energy from one point to another by means of molecule. Okay, so it is a disturbance of flow of molecules. The definition of wave. And then we have two waves, a progressive wave and stationary wave. So stationary wave is a whole different topic we will study later. For now, we will study progressive wave first. So progressive waves are the traveling waves we have, which have crest and trough as well. And let's read progressive wave now.
Progressive waves. Progressive waves are those in which energy transfer from one point to another. There are two types of progressive waves: transverse waves, the waves in which particles of medium vibrate perpendicular to the direction in which waves travel. Example: light waves, water waves, and all electromagnetic waves are transverse waves. Transverse waves consist of crest and trough.
Okay, so as I said that in progressive wave, it is a traveling wave.
Longitudinal wave, the waves in which particles of medium travel parallel to the direction in which wave travels. Sound waves are longitudinal waves. Longitudinal waves consist of compression and rarefaction.
Okay, so what is a progressive wave? Progressive is a traveling wave in which energy is transferred from one point to another. Unlike stationary wave, because in stationary wave, it is a standing wave, like it is not moving. So it is not. Oh, sorry, I got disconnected. Can you hear me now?
Yes, sir.
Wait. Can you see the whiteboard now?
Can, sir.
Yeah, so I was saying that progressive waves are the waves in which waves can travel from one point to another. Unlike stationary wave, they are just a standing wave. They does not travel. But in progressive wave, they travel and transfer energy from one point to another. So the energy is transferred in two ways. In transfer wave, it is different, and longitudinal wave, it is different. So in transverse wave, the wave or the energy transfer perpendicular to the direction of your medium, or you can say the source vibration. Like if I give you the example, if there's a rope, the rope, and while you are holding the rope, so the source is your hand. Okay, source is your hand, and the wave is traveling to the right. So if you move the rope up and down, what will happen? A wave will be created, right? So if you move your hand up and down, what will happen? Wave will be created, and the energy would travel to the right. So tell me the direction of your hand and the energy travel direction. Are they perpendicular?
Yeah.
Yeah. So if the direction of the source and the direction of the energy transfer or traveling, if it is perpendicular, we would be saying it is a transverse wave. So the definition is the wave in which particle of motion of medium vibrate perpendicular to the direction in which wave travel. So it is called transverse wave. For the examples, we have light waves, water waves, all the electromagnetic waves are also transverse waves. Okay, so one more thing that transverse wave consists of crest and trough. We know that a crest is a amplitude and the trough is also an amplitude point, but in upward direction. Is this thing clear?
Yes, sir.
Now read longitudinal wave.
Longitudinal wave, the wave in which particles of medium travel parallel to the direction in which wave travels. Sound waves are longitudinal waves. Longitudinal waves consist of compression and rarefaction.
Okay, so in the longitudinal waves, what will happen? Now we can take the example of a spring. If you say see the spring is something like this. Okay, so if you stretch the spring from both sides, you apply the force here and you apply the force here, and then you leave the spring. What will happen? Spring will move right and left. Yes or no?
Uh,
Yeah. So
yes.
it is the example of longitudinal wave. Why? Because now the position of your source, the position of your source is your hand, and your hand is moving right and left for stretching the spring. Right?
Yes.
You are moving your hands right and left, so you can say and also the direction of wave travel, it is also in the right direction, so you can say that they both are parallel. So if the direction of the particles of medium is parallel to the direction in which waves travel, you can say that waves are longitudinal waves. So the example of it are sound wave are also the example of longitudinal wave. Is this thing clear, a difference between transverse and longitudinal?
Yes, sir.
Okay, in transverse wave we used to have crest and trough, but in the longitudinal wave we have compression and rarefaction. You know that when you stretch the string will move right and left. So when it will move right, so you know there will be compression. But when it move left, it will move away, causing rarefaction. So you can see that the diagram here in the example in notes as well. When the particles are close, you say compression. When the particles are further apart, you can say rarefaction. So you can say that in longitudinal wave we have compression and rarefaction. Okay, is it clear that here?
Understand, sir.
Okay, the next thing we have is path difference. So we are now studying the wave properties. So in it we have the path difference. So tell me what is the meaning of path difference?
What?
Path difference. And do you know what is path difference?
The direction.
Sorry?
The direction of the wave.
No. So in wave we have two types of differences. It's a path difference and a phase difference. You can say it is a property of waves. You can also say that. So it is a distance between any 2 point on the in terms of wavelength. So what is the path difference? It is the distance between any 2 points on the wave in terms of wavelength. So if I say that if the wave is like this, so the one point is here and the another point is here. So tell me what is the path difference between these 2 points in terms of wavelength? Because path difference is always determined in terms of wavelength. Tell me what is the difference distance between point A and B? See,
Not sure.
A and B both are crests. They are the two consecutive crests.
Yeah.
So don't you know that the distance between two consecutive crests is 1
Wave.
lambda. Okay, it's the distance between the two consecutive trough or the crest. The distance between the two consecutive crest or trough. It is one lambda, and lambda is called the wavelength. The symbol is this symbol is called lambda. Okay, so you
Yes,
can
sir.
say that distance between the two crests and trough is called one wavelength or one lambda. So I can say the distance between A and B. I can write it as okay. Okay, now tell me if take this point C. Now tell me the distance between A and C.
So that means it'll be half lambda.
Half lambda because it is a half a wave. So you can say half lambda. Now if I take this point D, now tell me the distance between A and D.
1.5, 3/2
Yes,
lambda.
3/2. Right. And what about A and this point E?
2 lambda.
2 lambda. So part difference is the distance between any 2 points of the wave in terms of wavelength. So this is necessary in terms of wavelength. So we have calculated all the distance. You can see in terms of wavelength.
So was this in IG? No, right?
Sorry,
This wasn't in IGs, right?
can you write on chat? Your voice is lacking a bit. No, no, AS is right. It wasn't in IGCC. It is a new topic in AS level. We haven't studied this in O levels or IGCSE. It is a new topic. So yeah, okay.
Okay.
So in the above question, we have calculated a part difference using the fixed point. Like we know that the crest, trough to trough, or crest to half a wave. But in the question, you do not always get the exact point. Like if I say it is the wave, they would be saying calculate distance between point A and point C. Now it is not a fixed point like crest or trough because you already know that the distance between crest and trough is one lambda. But the points A and C are neither on crest or neither on trough. So in this case, we have to do some calculations to calculate it. So now we will be studying how to calculate the part difference between 2 points if they are not on crest or trough. First, let's make a wave. Just a minute. To you, this is the wave. This is the wave given to you, and now they are asking the find the part difference between the point A and D. Okay, this is a point D, so this is a point D, this is point A, and they're asking to find the part difference in between A and D. So you know now the A and D. D is on trough, but point A it is neither on the crest, neither on the trough, right?
Yes.
This point is on a trough, it is on a fixed point. But the point A it is not on the crest because the crest is here. This is the starting point, not point A. So point A is on middle of it. So for this calculating the part difference in these type of question, we have the formula number of divisions mean the boxes, the line. This is your boxes. The number of division equals to 1 lambda. So using this formula, we will calculate it. First, tell me. First, just calculate the number of divisions required for one complete wave. Number of divisions required for one complete wave. Just count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because this is these 2 points are consecutive crest. So can I say that the 12 boxes is equal to 1 lambda? Yes or no?
Yes.
Okay, because I just counted the boxes and that there are 12 boxes for the one complete wave, and we know one complete wave is equal to 1 lambda. Now, count the boxes between A and D.
Six.
No, A and D. One, two, three, four. Wait up. There are five, isn't it? One, two, three, four, five. There are five boxes, right?
So, sir, you don't count where it started from.
No, we don't take the starting point from A after A. So we won't be taking the A point, okay? Not the A box. After A boxes. So one, two, three, four, five, right?
Okay.
So for five boxes, what is the wavelength? We have to calculate. Just calculate the X. The answer would be 1 over 5 over 12 lambda, right?
Yeah.
So you can say I am taking here the part difference, and I am taking here the number of divisional boxes. So using this formula, you can calculate the part difference between any point. Either it is on the fixed point or either it's on any anywhere in the middle of it. So now calculate the part difference between A and B and tell me the answer.
Between A and
B, B for ball.
so 1 over 6 lambda.
1 over 6 lambda. One, two boxes here. Right, 1 over 6 lambda. So this is the constant formula you can use for any point. Just the formula is number of division equals to 1 lambda. You have to find how many number of boxes are equal to 1 lambda. 1 lambda is one complete wave. So using the ratio, then you can calculate the number of boxes for any points, right?
So, sir, in the exam, they'll give you the graph.
Yeah, they will give you a graph. Without the how it is possible. They will give you the label graph.
So,
Okay.
they'll give the division, the value of the division.
Yeah. The graph would be same like it, but obviously the division value you can calculate it at sometime they have given you if the axis is not labeled. Because in this graph I know I have taken one box as one. So one, two, three, four, five, six. It can vary in the question as well. Now tell me the path difference between point E and H. Point E and H.
3 by 4 lambda.
3 by 4 lambda, right? So is this thing clear that if a graph is given and we have to find any 2 points path difference, we can easily calculate it from this formula, right?
Okay.
Now the next thing we have is phase difference. So path difference was the difference between any 2 points, but in terms of wavelength, in terms of
Wavelength.
wavelength. But in phase difference, we also have to find a distance covered by wave, but in terms of angle. Okay, in terms of angle. So difference. Have you already studied this wave chapter in your college?
No, sir,
Not yet.
not
Then
yet.
till where have you guys studied?
We stopped at deformation of solid before holiday.
Okay, so we have completed till your college, so we have now ahead of them, right? Ahead of them.
Yes, sir.
Okay, so phase difference. What is a phase difference? It is a distance covered by wave in terms of angle. In path difference, it was in terms of wavelength, but here it is in terms of angle. That's it. That's the only difference. So there I said one wave was equal to one lambda, right? It wasn't path difference. But in phase difference, I would be saying one wave is equal to 360 degree.
Okay.
Or I can say one wave is also equals to 2 pi radians. So you know that we have two units of angle, degree and radian. So it is up to the examiner in which unit they want the answer. So if they are asking about in radian, so you can say 2 pi. If they're asking about degree, you would be saying 360. Okay? So you can say one wave is
Okay.
equal to 360 degree, one complete wave. So the distance between two consecutive, the phase difference between two consecutive curves or curves would be 360. Now let's take the same graph, but now instead of finding the path difference, we will calculate the phase difference. So again, the question is write down the phase difference between the point A and no B and D. Calculate the phase difference between the point B and D. So the formula would be remain same, but instead of 1 pi, I would be writing
360.
yes the angle because it
360.
is the phase difference. So we'll be writing the angle. So number of divisions is equals to 360. How we have to find how many divisions is equal to 360 degree or one complete wave, and then you can find it for any point, any 2 points. So I can say 12 box was equal to the 360 degree, and if we have to find the phase difference between B and D, so one, two, three divisions are there. So three came here. The answer would be 360 into 3 divided by 12. Okay.
Yes.
Now calculate the phase difference between the point B and E.
B and E, right, sir?
Yes, B and E.
So 150 degrees.
150 degrees. How many boxes are there? There are one. Okay, right. So is this thing clear to find how can we find the path and phase difference?
Yes, sir.
The question can come like the graph question can also come, or sometime without graph, the questions can also come like this. I can say the speed of the. Now, okay, read the first part.
The speed of the waves is 32 cm per second and its frequency is 6 Hz. Find the path difference between 2 points which are 2.2 cm away.
Find the path difference between the 2.2 centimeter away. Okay, so now instead of using the number of divisions formula, we have to rephrase it. So the thing is that we have to find the path difference between point which are 2.2 centimeter away. So if I find that the distance between one complete wave is equal to, you can say the distance of one complete wave is equal to dash. So if you have to find that path difference for 2.2 centimeter, you can calculate the x, right?
Yes, sir.
Now we have to find the dash first of all. So we have to find the distance of one complete wave. So we know the formula for, we've already studied in before in O levels. Velocity is equals to frequency
We,
into
uh,
lambda, right? So lambda is equals to velocity upon frequency. So velocity is 32 and the frequency is 6. So the lambda becomes 5.33 centimeter, right? So now can I
yeah.
say that the distance of one complete wave is 5.33 centimeter? So now I will put here. So one lambda is equal to 5.33 centimeters. So now instead of number of division, I have inserted the proper length or distance, right?
Okay.
Now just calculate the x. So x would be 2.2 divided by 5.33.
Okay.
So your answer 5.33 centimeter, but 2.2 into 1 lambda. Don't forget to write lambda because we have to find the answer in terms of lambda. So the x would be 0.41
Oh,
lambda.
yeah.
So is this question clear?
Yes, sir.
So the question can come without the graph also. Now read another question.
The speed of the waves is 40 cm per second and its frequency is 8 hertz. Find the phase difference between the points which are 0.625 centimeters apart.
Okay, now instead of path difference, they are asking us the phase difference, right?
Yes.
So we will use the same formula, same logic, but now instead of distance, I would be writing angle. That's it. So I can say that 1 lambda is equal to 360 degree.
Degrees.
We already know that. So first of all, calculate the lambda first. So V equals to frequency into lambda. Your lambda becomes 40 over 8, 5
I,
centimeters, right? So now I will be using the ratio 360 degree is equals to 5 centimeter. So if I have to find the degree of point which are 0.6 to 0.625 centimeter away, I can use this ratio. Yes or no?
yeah.
Right? So the main thing is ratio. We just have to use a ratio for this type of question. So we already know that the one lambda is equal to 360 degree. So we already have a distance for one complete wave. So I can take it as equal to angle as well. Yes or no? So 360 is equal to 5 centimeter. If 360 is equal to 5 centimeter, then how would be the angle of 0.625 centimeter? Did you get this ratio?
Understand, sir.
Now tell me the answer. What is the answer coming?
45
45, right?
degree.
Yeah. Okay. Now the next thing we have intensity. Intensity of a wave. Okay, so what is intensity of a wave? Intensity of a wave is the power of the waves per unit area. Power of the wave per unit area covered by it. So I can say intensity is equal to power upon area, right? So the unit for intensity would be watt per meter square. So if you have to find the intensity of a wave, that how intense a wave is, so you just have to divide power by area of the wave. Is this thing clear?
Yes, sir.
You can further rephrase the formula as well because we know that power is equal to energy over time. So I can replace power by energy over time. So it would be energy over time into area as well. So you can use either of the formula according to the data given to you for intensity. E stands for energy in joules, A stands for area, T stands for time in second. Now there are some factors on which the wave dep now there are some factor on which the wave intensity depends. So the first factor on which the wave intensity depends on amplitude. You know what is amplitude?
Yes, sir.
What is it?
The
Define it.
distance between the highest point and the center.
Yeah. So